Welcome back to Obsession Engineering. That on the bench that's in a few pieces is my SP1, and today we've got an important job. Arguably the most important job, because it will be the thing that makes the biggest difference when the bike is back together as to how it rides, and that is the rear shock. So a bit of a recap if you've missed any bits of the SP1 project. This is a almost completely original 18,000 mile UK SP1 first year, SP1 SPY, Honda VTR 1000. I've ridden it on road and on track, and the biggest problem with it is the rear shock. Basically the bike sits too low and too soft, and so on the way out of corners the bike just squats down, it tries to run wide, it's hard work to steer, loses all accuracy, it's just a bit pants. Because I already had the exhaust pipes off to reseal them and give them a bit of a clean, it has given me easier access to get the shock out, so I've not rushed to put them back in. The first thing I need to do is take the big bolt out the top of the shock, or at least the nut off it, and then we go down to the linkage and we need to undo the big bolt at the bottom of the shock. But while I'm here, I'm also going to service the linkage, basically just strip it down and re-grease all the bearings, and so I need to take all of the bolts out of it so I can take the whole linkage out, and that actually makes access to the bottom of the shock easier as well. So right, let's talk more spanners. So I like to get in here and undo all of the nuts from the linkage first. This one I had already loosened. Take them all off and put them somewhere safe. Foot under the thing. Just drop that link out of the way. Then I need to just put something, a bit of wood, a bit of block under the wheel. It's better, just a bit better supported. And now I can easily get to the bottom shock bolt. By the time you've got all the linkage bolts out, you might find that some of them are very similar, but just slightly different in lengths, especially the top and bottom shock bolts tend to be. And so I try and lay them out in order of where I took them out from. You can, of course, just put a little mark on them with pen or something like that, because it's very easy to get them in the wrong place and have one that's not quite the right length for the nut when you put it all back together. Also worth remembering which way round the linkage all goes for when you put it back together. The links, sometimes you can put them in the wrong way round. TZ250s you can, and it took me hours to work out why I couldn't get the bike to work properly. And so it's always worth, if you need to, just put a little mark on it or take a photograph of it, or some video, so you know exactly how it goes back together. So I can take the last bolt out of there, and I can also take the top shock bolt out and lift the shock out. And because I need both hands free to get the shock out, because sometimes it's a little fiddly, top shock bolt out, and I'm going to put that separate to all the other bolts. And on the SPs, these shocks come out pretty easily. I might just have to lower the wheel down the swinging arm a little bit to get it out, but there we go. Pretty straightforward. So this is the standard rear shock out of my SP1, and to be fair, it's not immaculate. The plating has gone somewhat tarnished at the top there, but there's a little bit of rust in a couple of places, but it's actually not really in bad condition, and with a thorough clean and a polish it'll probably come up relatively nicely. What I normally do with these, and what I probably actually will do with this one in the end, is split it all down into pieces, and all the steel parts I'll send off, get them replated, re-powder coat the spring, repaint the sort of plates at the bottom here that go a bit rusty, and make it look absolutely like brand new. But I don't need to do that with this one, because this one can go over there. This is also an SP1 rear shock, and this one is in lovely condition. Since I built Henry's Honda a couple of years ago, I've had a reasonably constant stream of people wanting SP1 and SP2 rear shocks, making it look like brand new, and so I actually taken to having one or two in stock, buy them from breakers and take them apart and make them look nice to trade in with people. When I bought this one, it turned up and it was very, very clean, and so I've had the spring powder coated and it looks lovely. But it's not actually the last thing we're going to be doing to the shock, because this one hasn't been apart, so everything inside it, the oil and all the seals and everything, are over 20 years old, and so they're obviously not going to be in peak condition. So what I'm going to do is take it apart, service all the items inside it, and then change the spring. Because the biggest problem, I believe, on my SP1 isn't the shock itself, it's actually the spring. Having done sag settings and measurements on quite a few SP1s in the past, what I know is, with the preload wound all the way up, which was how the bike actually rode best on the road, we won't actually have the sag setting I'd normally try and get for a road bike. On track I normally aim to be about 30mm with the rider on it. On the road you want to be around 35mm. This will be in the 20 to 25mm range with the adjuster wound all the way up. And there is a reason for this. Honda seemed to have fitted quite a soft spring, but then put lots of preload on it. So interestingly, over the bumps, it's actually not very good because it's got so much preload, it just transmits the bump straight into the bike. But when you actually put some real load on it, the spring can't cope because it's too soft. And so what we need to do is fit a stiffer spring. There aren't actually many springs available for these, certainly not in the weights I'd want to go to, and so we're having to do a little bit of adjusting. But the first thing we need to do is get a measurement for exactly what we have here. And so we need a spring length measurement, like a pre-loaded measurement. So as the bike rides best, we have a measurement of 182.5mm. I shall write it down. And now we need to take the spring off and measure how long it is when it's fully extended. See how much spring preload we actually have. To get the spring off the shock, we're going to need a spring compressor. So this is basically a frame with a hydraulic jack in that compresses the spring section but leaves the sort of shock body loose so I can take the plates out the end that actually locate everything together. I made this one myself. It's done many years of good service. Now we have the spring off, we can go back to some more measuring, and this gives a free length for the spring of 208.5mm. So to make this spring work in that SP1, it had 26mm of preload on it. And obviously, if you don't know about preloads on springs, that is a ridiculous amount. In general, on a sort of BSB level race bike, a superstock bike, whatever, I would normally aim to run between 12 and 16mm of sag, of spring preload. So if you have the correct spring, you should only need up to 16mm of preload on it. 26mm. So that is substantially too soft. So if we want to work out what spring we actually want, we can turn it into a maths problem. And maths was not my strong point, so if I've got any of this wrong, please write in and complain. Write your postcards to davedoesn'tcare@Obsession Engineering. Right, we have a 93 Newton per millimetre spring as standard. And to get the preload how I want it to actually get the bike to ride properly, I've got 23mm of preload in the spring. So before the spring even moves again on the shock, we have to apply 2,418 newtons of pressure to get the spring to compress, which means over the bumps, until we've hit that amount of pressure in the spring, the shock won't move. And obviously we understand there is a linkage and a ratio, and so it doesn't mean you have to be really, really heavy to get the spring to move, because it's all on a linkage. If, for example, I had a 110 Newton spring, and I wanted to divide that number by 110, I would need 22mm of preload on the spring to get the same point static at its sag point, or as the bike basically sits. But it's not that simple. If I have a stiffer spring, because we have a 63mm stroke in the shock, if, for example, I want to be halfway through the shock stroke, which is actually where the problem's really coming in, I've got my 26 plus half my shock stroke length, which gives me 57.5mm of load into the spring, times your 93 is 5,347.5 newtons. If, for example, my 110 Newton spring, I need to get to the same point, because I've got less preload on it to begin with, but I've still got the same amount of stroke. To get halfway through the stroke on my 110 Newton spring, even though it's not preloaded as much, I'd need 5,885 newtons of pressure. So even though I've got a little bit less preload on it, by halfway through the shock stroke, it's quite a lot stiffer, which is what I want. I want less preload on the spring to begin with, so it'll actually go over bumps as well, if not better, but in the middle of the stroke, it's going to be better. If I go really, really stiff with the spring, though, the damping might not cope with it terribly well, because the damping is set up for a 93 Newton spring. It isn't ever quite as easy as you think. So my theoretical 110 Newton spring will give me a distinct advantage halfway through the stroke, and it might mean that I can actually have less preload on it to begin with, because once it starts moving, it'll be stiffer anyway. And hopefully that makes some sense. And even that, we can muddy the waters a little bit more. So we're going to talk anti-squat and how important it is into how the bike is supported on corner exit. And basically anti-squat is how much the chain pull will actually try and pull the swinging arm down or pull the swinging arm up. To be fair, it's how much you pull the swinging arm down is anti-squat, because it stops the bike squatting. It's anti-squat. If the swinging arm goes that way, it's pro-squat if the chain is pulling the swinging arm down. This is a relatively complicated subject, so I'm just going to try and simplify it as much as I can. If the swinging arm is dead level, there is no anti-squat. So as the chain pulls, as the front sprocket pulls the chain tight, it's just trying to pull the swinging arm shorter, basically, and the swinging arm will stay static. If we take our block of wood from under the wheel, you can now see there's quite a big angle in the swinging arm. Now, if you pull that chain tight, as in the front sprocket's pulling it tight as the bike is in motion, it will actually try and pull the swinging arm down even further. That's anti-squat. If you go out on your bike today, if you hold the front brake on and just tease the power with the clutch at standstill, you'll actually feel the back of the bike raise up. And this is what's happening. The chain is trying to push the swinging arm down to get that as close as it can to the engine, and that's anti-squat. And that is all to do with your ride height as you're riding your bike. If we pretend that the shock is really compressed, so the swinging arm angle is actually that way, what's then happening is, when the chain pulls on it, it's trying to pull the swinging arm up. That's pro-squat. It's making it squat even more. So, obviously, when you are accelerating on the bike, the weight of the bike pushing on the shock will want to make the shock squat. What we really want is the force of the chain, the anti-squat, to act against the squat, so the bike actually stays in a perfectly flat plane. What I believe is happening with the SP1 when I ride it is, because the shock is relatively soft, the spring is too soft, and the back of the bike is quite low, when you accelerate, the shock pushes down because it's not squatting enough, the anti-squat can't hold it, and then of course it goes into pro-squat, and then it sinks even further and basically makes itself into a mess. There are two things you can do to combat squat. The first one is obviously to fit a stiffer spring. With a stiffer spring, the bike will naturally sit higher, especially when the bike is in motion. If you put lots of preload in the shock, which is how Honda tried to fix it, that does help at standstill, but when you're riding the bike it doesn't help anywhere near as much. Because I actually want to have less preload but a stiffer spring, there will be points when this isn't going to be any better than the Honda setup. And so to fix that, I'm going to put some more ride height in the bike. The shock does not have a ride height adjuster, but if I put a small shim on here above the shock mount, it will basically push the shock down and raise the bike up. And that will give me a sharper swinging arm angle, and that will give me more anti-squat, and that combined with my slightly stiffer spring should give me a much better riding dynamic, even if my spring isn't massively stiff. And I know what you're thinking, and stop. If we have too much anti-squat, which you think right now will be a great idea because the bike won't squat at all, that isn't going to help us. There are three issues though if we have too much anti-squat. First, the shock basically doesn't move, so it doesn't actually go over bumps very well. Secondly, the bike will be prone to wheeling more because it can't transfer weight onto the back, so it has to pivot around the back wheel. And the last one is, when we first tap the throttle open, the chain pulls the swinging arm down too much and basically forces the back wheel away from the bike. And then you crash. And we definitely don't want that. But enough of the theory. What I need to do is take that spring off and put a stiffer spring on. maybe this spring will do the job. The other game we're having a little bit with this shock is, because it's an ever so slightly odd length, trying to find a shock spring that's a similar length that will give me the right amount of preload and is a similar diameter has been a bit of a game. So I have a 110 Newton per millimetre spring, but it is ever so slightly the wrong diameter at one end. So I need to go and do some modifying. A bit of fettling downstairs, basically trimming out a little of the inside diameter of the spring, means that that spring, along with this little spacer, this sort of preload spacer, now fit on the actual shock bottom. This is sort of the bit that captives everything together, so they all fit on there surprisingly nicely, and that means I could fit that spring to that shock and my bike would be better. But the oil in that shock is still over 20 years old. So what I now really need to do is take this completely apart and service it properly. So as with the original shock, I've taken the spring off it, the bits that actually adjust the preload, and the cover plate that covers the gas reservoir. But it's a good chance to actually check whether the shock works properly. So if I push down on it like this, there's a good level of damping, there's good control damping on the way back out, and the gas pressure is pushing the rebound adjuster in, the shaft out even. So we know that works. Right, just wind the rebound adjuster all the way in, and that will basically lock off the whole shim stack and thus lock off the compression as well. And there we go, it's quite stiff, but being a road bike you can't ever really lock it off, and you can see how much difference that makes to compression and really to rebound. So we'll wind that out, and then just to make a bit of a demo, if I have the compression adjuster wound all the way out, it moves like that. If I wind it all the way in, it doesn't make a massive difference, and I shall explain it more later, but basically the rebound adjuster affects compression and rebound. The compression adjuster is basically decoration on the top. Right, the next thing I need to do then is let the gas pressure out, take the end of this plate off by pushing it in and removing a circlip that's in here. Then we can pull the bladder out of it, start draining the oil. So this is the bladder that goes in here, and the reason you have to have the gas pressure in here, there's two reasons really, is the first one is the gas pressure helps stop cavitation in the oil. So basically if the oil is under pressure, it's less likely to cavitate, which means you're less likely to get air bubbles in it as it's working, which means it stays more consistent. The other reason is, obviously, as the shaft goes in to the shock, that displaces oil. Obviously, it can't share the same space, so the oil has to be pushed into here, and you need something to push it back out again afterwards. Right, here we go. What does this look like? That's actually not too bad, but there won't be all of it. There will be some in here as well. But you can tell this shock's actually not done a lot of mileage, because sometimes that oil comes out black as a shadow. With most of the oil drained, I now need to take the other end of the shock apart, basically get the piston and the seal head out of here. And so I've just knocked that up, and that literally just knocks up with a little punch. And a bit like at the reservoir end, at the bladder end, this seal head needs to be pushed down a little bit so that we can expose the circlip that's around the edge, and then you flick the circlip out, take the seal head out the top. I'm going to be honest with you, changing the oil in the shock is the most critical item because it's the bit that works the hardest. But while I'm in here, I may as well change all the seals and the bushes and clean all the shim stacks and all that sort of stuff as well, because that's a bit more of a proper job. Now, I've already been down and I've been on the grinder and sort of chamfered the end of the shaft, because the nut is locked by peening the end of the thread over, so you need to grind the end of the thread over to get the nut off. I have tried winding the nut off before and then cleaning the thread afterwards, and trust me, this way is easier. So I'm going to take the nut off and then lay all the bits in order out on my bench. So this is all the bits of my shock laid out in all their glory. So that is the shaft, bump stop, which is basically just sort of hard rubber, cover plate thing to keep the weather out, seal head. So this has got a dust seal and then a bush, and then inside there's a oil seal, and obviously the seals on the outside and bits as well. And then we have actually that, and these two bits are just spacers, and then these are the compression shims. So when the bike is in compression, oil is flowing past this piston, and it'll be going down the bigger of the holes there, and that pushes it through and into this area here, which is sealed against the shim. And then if the shock goat wants to keep moving, it has to push the shim out of the way. So basically these shims are flexible, and so the more oil pressure you have pushing on the shim, the more the shim will flex out the way. If we go back to the shaft, there is a bypass hole here that comes out at the end here, and that is adjusted by the rebound adjuster. So basically, if you wind your rebound adjuster in, it blocks off more or less of this hole. So if you wind the adjuster all the way in, it basically locks that hole off, which means all the oil that is passing past the piston has to go through the shim stack, which is why the damping gets stiffer. If we want to alter the actual damping characteristics in the shock, how it goes over bumps, how it reacts at different points, then we have to either alter the actual piston design or the shims. So normally when people say they're having their suspension revalved, they're altering either the shape or the thickness of the shims or the number of shims, maybe altering the piston design, and they've got to take it all apart. To do all of that, right, the other side of these bits are the rebound shims. So obviously when the shock's going the other way, the oil goes back past the little holes in there, onto the little holes there, which push on the back of the shim, and again that just flexes out of the way. So basically, if you're going up and down slowly, then most of the oil will go past the bypass hole unless you've got it locked off. Once the shock moves a bit faster, then it has to go, the oil has to go through the piston and flex the shims out of the way, and the faster the shock needs to move, basically the bigger the bump or the more load you're putting into it, the more it flexes the shims out of the way, the more shims are relevant, and the more damping you get. Simple, really. This is my standard piston and shim stack, and I was looking for options to maybe make it a bit better. And then I remembered on the shelf I had a K-Tech piston kit. Now this isn't actually listed specifically for the SP1. It's listed for ZX6s, CBR 600s, CBR 1000s, ZXR 750s and quite a lot of other stuff, and is almost the generic 40mm like Showa or Kayaba shock piston replacement from K-Tech designed for road use. I think the reason this isn't actually listed for the SP1 and SP2 is because the actual height, the shim stack of the piston and the shims, is 14.7mm on that and 17.1mm on the standard. And obviously we have a few spaces and bits to make up a certain gap anyway. So if I remove one of my Honda spacers and fit another generic spacer I've got off an old piston kit from something else, I can get the K-Tech piston kit to fit in my SP1 shock. So that is what I'm going to do. But before I fit that, I need to change the seals and the bush in the seal head. Inside the seal head that I've now stripped down, there is a bush which you just press out. A 10mm socket is especially good for pressing that out. That is the main oil seal, with the original has like a little sort of cone to locate it properly, and then there's just like a bottom bush to stop when the shock tops out going metal to metal. That's just the dust seal, and that's the O-ring that seals the outside of the seal head. And all we need to do is get a service kit from K-Tech and swap all these bits out. So I just need to press a new bush in, pop some new seals in, start putting stuff back together. So time for reassembly. The thread at the top of the shaft, I've just been around it with a needle file and made sure the new nut will go on nice and easily. I have my rebuilt seal. I've got a bit of grease around by the actual seals themselves. I've got my seal bullet on there so I don't damage my seal while I'm sliding everything together. So that is seal head on. And now, with my altered shim arrangement, I can put my K-Tech piston on. I've jumped ahead and put the bladder back in the reservoir. I've put a bit of K-Tech shock fluid in the body, and I've moved it around a little bit to try and get the air bubbles out of the reservoir. And now with a mountain bike shock pump, I'm just going to put about a bar of pressure into the bladder just so it expands and takes up the correct amount of volume in the shock. And then I can refill pretty much all the way up with the suspension fluid, with the oil. With the shock body now mostly full of oil, we can drop our piston assembly in, and nice and carefully, because it will try and squirt oil everywhere if I'm doing it too quickly. In fact, you can see there the bypass holes. The oil is bypassing the shim stack to come out of there, so I'm just going to push that down, and you can see some air bubbles coming out. And I'm going to work it up and down a few times quite gently to try and get the majority of the air out. And then I'm going to lock the rebound adjuster off, give it a bit of a tap a couple of times with a soft mallet, and that will just force the oil to go through the shim stack and push the air bubbles out the shim stack. It's actually more important to be sort of aggressive on the compression stroke than it is on the rebound. If you try and pull the shock back out too quickly, what you tend to do is cavitate the oil, get a load of more air in it, and then it just takes you even longer to bleed it up. So I've been bleeding that for a couple of minutes now, and I'm confident we've got most of the air out of it. So I'm just going to leave it for a couple of minutes while I grab some lunch so that the last air bubbles can dissipate out the oil. Today I am going through the process relatively quickly because I've done the shock rebuilds in quite a lot of depth before on the Henry's Honda video and Mazda X10 video, and so I thought I'd mix the style up a little bit. If you like the faster version, let me know in the comments. If you like a cure for your insomnia, put a comment in the comments as well, because comments is where the comments go. And if you like the look of my hat, or you want a hoodie or a t-shirt or some other merch, check out obsessionengineering.co.uk and go shopping. Lunch eaten, so now what I need to do is just lift this up a little bit, take the plate out, and when I've got two hands, actually make sure there are no air bubbles in my oil, give the piston one last gentle stroke up and down to make sure there's no oil bubbles in it, and then I need to push the seal head into the shock body. And obviously as I do it, it will trap some oil in there and it will try and push the oil out the way, which it won't be able to get out the top. And so as I'm doing that, I'll have to release some of the pressure in the bladder so that the seal head can go in, put the circlip on it, and then we won't be far off gassing up. I have the shock set up in the vise, the seal head is back in, and I've compressed the shock as much as possible to get as much air out of the reservoir as possible. And I have my regulator set up, my gauge even set up, and so we're going to pressurise with our nitrogen supply. So as I pressurise it up, you can see the shock extends as the gas pressure pushes the shaft out, and we're going for 10 bar of pressure. So I've got 10 bar on my gauge there. Excellent, yep, there's 10 bar in the shock. Right, and now we can take it out of the vise, give it a bit of a clean to get some of the excess oil off it from when I put it back together, and actually check if our damping works. So now I have a complete resealed, re-oiled, revalved and pressurised up shock. What I'm going to do is, with the compression and the rebound adjusters locked off, right, that's taking all of my body weight to push that down, but it's nice and consistent. I can't hear any air in it. I can't feel any like real easy bits of movement through the stroke. We'll do that again. Basically, if there's any air trapped in it, you often get like a tiniest little bit of movement when you first shove on it, but no, I'm happy that that is absolutely spot on and we've got no air in it. Then if we open the rebound adjuster all the way out to begin with and give that a shove, you can see how much easier that moves in compression and in rebound. If I open the compression adjuster up, you see it doesn't really make a lot of difference. Now obviously there's a little smear of oil and bits as I pump it up and down the first few times because I greased the seals up, so I don't mind doing that a couple more times. Nothing excessive, which is always good to see. Right, I'm happy that with that I can now put my new spring on. And there we have it, my fully rebuilt, revalved and re-sprung rear shock. The original shock had 26mm of preload on it in the way I last rode the bike, when it actually rode best. I'm starting with 18mm of preload in this one, which is still quite a lot, but it's considerably better than what we had before, and I have got options to go both ways on it, so when I test ride it, I can test it. So I think it's time to go and put this somewhere near a motorbike. I've machined up a little 4mm spacer up the top of the shock so that we've got a little bit more ride height, and that has meant that my nut is just still on the actual locking mechanism of the nut. So I could have gone a little bit higher on the ride height, but then I'd have had to have Loctite the nut and it wouldn't have been quite so nice. So the shock is in, but there's no linkage yet, because that is over here. I've given it a little bit of a clean externally, and now what I need to do is one by one push the rollers out like that, get a really good smear of grease in the rollers inside, in the actual needle bearings, and then make sure the rollers are nice and clean, pop it all back together. Right, that is all my linkage bearings re-greased with some Motul Tech grease, so they're going to be well looked after for a good few miles, so I can put that back in the bike. I don't normally grease bolts, but I've greased the head of this bolt because it actually comes through and actually sits inside the frame there, and so a bit of grease on that will just help it stop corroding the bolt basically into the frame, and so if I ever take it apart again it will be considerably easier. Linkage back in and torqued up. All of the nuts for the linkage and the shock are 44 Newton meters, so that is it. The shock is in. Revalved, serviced, resprung, different preload setting, different ride height setting. This is quite a significant change to the bike, and I think it should work very well. I'm not actually going to find out until I ride it, but at least I've got something to look forward to. So that's another bit done on my SP1, and I would argue probably the most important bit done, assuming it all works, which I'll find out when I go and ride it. And what I could do now is throw the exhaust pipes on it and put it all back together in a rush of excitement. But it's actually Sunday afternoon and the weather's quite nice, so I want to go outside and ride around on two wheels. So we're back soon to actually finish the bike off.